Hello, and welcome back to another video. My goodness, it's been a while since I uploaded, and I have something a little different this time. I'd like to focus my videos a bit more on the programming side of things, because it is something I am very passionate about. And I noticed there is a significant lack of coverage for this programming language, so I decided to take it into my own hands and mess around a little. Have you guys ever heard of the esoteric programming language, brainf? I do not like saying swear words, so I'm bleeping that out. And for the rest of this video, will just be calling it BF, which is similar to the YouTuber Portal Runner's way of doing it, and his video on making a snake game in this programming language is definitely a huge inspiration. Now, it's time to actually explain what the heck BF is, because I have a feeling not a whole lot of people know about it. Compared to other esoteric programming languages, it is actually pretty well known, but it's still esoteric, and for a good reason. BF takes place on an infinitely long tape of numbers that start out as 0 and can go up to 255. If they go over, they just wrap back around again. This is because BF deals with 8-bit values, which does sometimes restrict you, but is relatively easy to work around. That is probably the least of your concerns, though, as BF has only 8 instructions that you can actually use. BF uses a pointer that points to the tape, which means you can only interact with one data bit at a time. The comparison symbols, which look a bit like arrows, move your pointer back and forth across the tape. And the plus and minus symbols simply add one or subtract one. The comma takes an input using a lookup table called ASCII, and the period simply takes the number that's at the current cell and outputs it as an ASCII character. For example, the ASCII code for the opening parentheses is 40. So if you type that on the keyboard, it sets the cell to a 40, whereas if the number is 40 and you use the period, it'll output the opening parentheses. And then there are the brackets, which are definitely the most complicated symbols of the group. If the current cell you are on is a 0, the loop is entirely skipped. And if it isn't, it'll start running the loop. Everything inside is run, and when you reach the closing bracket, if the value is still not a 0, it runs the loop again. Otherwise, it exits. So it loops if the number isn't 0, essentially. And that's everything. It's the entire programming language. Every other character is ignored. Yet somehow, people have made entire 8-bit games, Bad Apple for obvious reasons, because of course they have, and a billion other things. Because BF is Turing complete, which is fancy pants terms for it can do anything that any other computer can. But it's not exactly easy to work with, which should be obvious from what you've seen. So I decided, in my infinite wisdom, why don't I spend like a week or two using BF to write an entirely new programming language. Isn't exactly a new one, but I essentially used BF to write a compiler, which is a program that turns one language into another, that allows me to turn a more complicated version of BF into normal BF, which makes it easier to work with. And this video is kinda just describing the various changes I made, and talking about how much pain it takes to implement something so basic in BF. And this is the program. And it appears that my screenshots are not very easy to read. I mean, BF is already impossible to understand without taking notes on everything. But now this is even more than usual. So I guess I'll just have to describe it a bit. If you feel like hurting your eyes to look at the screenshots in the background, fine by me, but I guess don't say I didn't warn you. The way that the program works is at the very start of it, it sets up the area. It sets up a marker, which is a number that I can easily go back to using a special set of instructions, and 3 spaces for input. That might seem like a lot, but it'll make sense eventually. And then there's, I think it's 14 different flag cells, as I call them, which we'll explain later. And then there is the next marker, which is used primarily just to separate that whole thing. And then there is the code, which is where all the output code will be stored. The way that the program works is it starts by taking an input using the comma. Then we need to duplicate it, which is surprisingly complicated because you need to subtract from the main cell and add 1 to 2 other cells and repeat that, and then you have to take one of the cells and move it back to the original spot because of how BF is, it's just so annoying to deal with. But it's kind of fun. So we push on. Then we use a system that subtracts from the duped output and checks if the result is equal to 0. And if it is, it just skips it. But if it isn't, it goes to the flag space correlating with that symbol and sets it to 0, which means it'll be skipped if we try to check for it. That is how we implement if statements. That took hours. But now the system is modular enough where if I can find a way to write the code, I can make tons of new symbols. The new symbols include the parentheses, which allow you to write an actual normal if statement by checking if the thing is 0, and if it is, it runs the code. Otherwise, it does nothing, which is the opposite of the loops. But this also doesn't loop because it sets the cell that it ends on to 0 as well, because coding stuff. The next set of symbols are the underscore, which will set a marker somewhere in the code. But this marker does not interfere with anything else, because this version of BF that I created has 3 tapes instead of 1. One of the tapes is dedicated to markers. You can set a marker with underscore, remove it with the tilde, which is the button right next to the 1 on most keyboards. There is then the curly brackets, which kinda look like arrows. I couldn't find any better symbols that are on a keyboard. And they will move you to the left, the nearest left, or the nearest right marker. And then we have the final 2 symbols. Didn't add a whole lot of stuff, but it's pretty useful. We've got the register tape, which is a tape solely for just storing various data you might need later. For example, the caret, or the exponent thing, if you're a math person, sets the current register, I guess you could call it, or the data cell at your position to whatever the current cell's number is, which allows you to store variables in a way. I have plans to expand upon this in the future, but that'll need some work. And then the final symbol is, well, the equal symbol, which just takes the data of the register cell and just puts it on the normal tape. Pretty simple. And that's all of them. That's every single character that I added. They may not seem like a lot, but they make adding stuff or making games way easier. My next video that I'm working on will be a basic 2D game of sorts written in BF#, which is what I'm calling this edited version of BF. I will have a download link. Well, it's not really a download link. I'll just have the source code for the compiler just in the description. If you feel like running it, there's plenty of BF interpreters out there. The way that it works is you just write your code in an input box, which most interpreters will have, and then you just take the output, and that is your functional BF program. So yeah, just copy that, and you should be good. If you need interpreters, I would highly recommend the one on tio.run. It has every kind of interpreter you could need, and the BF one is decent. And that's the end of the video. I hope you all enjoyed this little adventure into BF, and I will be posting a little bit more content related to it, because it's a programming language that interests me greatly. If you liked the video, smash the like button, subscribe, bell, all those things, and help this little channel of mine grow. I don't see a whole lot of BF and stuff programming content out there, and I'd like to add a couple pieces to the pile, I guess. I hope you all enjoyed, and I'll see you in the next one.